Okay, everyone, let's head over for our next session, this time from Marcus, and he talks about from fragile to resilient, using admission policies to strengthen Kubernetes. Welcome, Marcus, and yeah, let's start.
Thank you. Hi, everybody. So, as Engin said, I'm Marcus Noble. For those of you that don't know me, I'm a platform engineer at GiantSwarm. I currently work on release engineering, CI/CD, and kind of core Kubernetes development stuff. So far, I've got, I think it's now about 7 years experience running Kubernetes in production environments. I started off my Kubernetes journey as an app developer. I was doing Node.js apps, and we were deploying it to Kubernetes clusters just within our team. So we had 3 clusters, dev, stage, and production. I then moved into a more DevOpsy role where I was managing those clusters for the team. Moved further into a more R&D role where I was building out tooling and best practices and things like that for an entire company, a global worldwide. And then more recently moved into more platform engineering and CI/CD and things like that all around Kubernetes. The reason I tell you this is because I've gone through a lot of the different pain points that a lot of users have with Kubernetes in different areas. So I've been on the app side of things. I've been on the ops side of things. I've had to deal with things going wrong and all this kind of stuff. So hopefully, what I say you'll take from that experience. If you want to get in touch with me anywhere, I'm on the Fediverse at marcus@kh.social, or I'm on all the other social platforms. You can find all the links at marcusnoble.com. So let's crack on. Dynamic admission control. So validating admission webhooks and mutating admission webhooks. For those of you that may have seen me speak before, you may know that I've kind of got a bit of a love-hate relationship with webhooks within Kubernetes. Just so that we're all on the same page about what I'm talking about, these webhooks are generally used for 4 main areas that I see. So you'll often see them use a lot of defaulting logic. So this is where your mutating webhooks come into play. This is things like automatically injecting image pull secrets into all pods created within a particular namespace so that you don't need to give those credentials to your app developers, for example. You can handle that as a cluster admin. There's also policy enforcement. So this is where your validating admission policies validating admission webhooks often come into play. So if you have a policy within your organization never to use mutable image tags, such as the latest tag, you always want to make sure that you're relying on a known tagged release. You can have a validating admission webhook that will prevent your teams from using that. You've then got best practices. So if you want to enforce the use of things like horizontal pod autoscalers or pod disruption budgets and things like that to make sure that your teams are deploying things in a way that's going to be resilient and not go down on Black Friday, for example, you could do that again with a combination of validating and mutating webhooks. And then my favorite area is this thing that I call problem mitigation. So who here remembers the Log4j issue from a while back that basically affected the entire internet, right? Everybody seemed to be panicking about this because it was such a widespread vulnerability. There was in a lot of Java applications. The way to effectively turn off the code path that was vulnerable was setting an environment variable to a specific, I forget what it was exactly now, but you set a specific environment variable and it turns off that code path that was then exploitable. What we were able to do at GiantSwarm for all of our customers, all of the clusters that they were running, is use a mutating webhook that every time a new pod was created, it automatically injected that environment variable into all of the containers within that pod, which meant that without our customers doing any work, they were immediately safe from that vulnerability in all of the new pods that got created within all of their clusters. And all we had to do was deploy this one mutating webhook. Brilliant. And there's lots of examples of this that you can do. But while webhooks in Kubernetes are powerful things, there is some risk that comes with this power. Now, this is not that talk. I've actually given this talk last year at Rejects in Chicago about all the ways that webhooks can go wrong and cause havoc, frustration, and pain for you as cluster admins in your clusters. If you want to see that, there's a link, there's a QR code for the link down at the bottom. You can find it on the Regex YouTube page. But what I actually want to talk about today, rather than these risks, is wouldn't it be great if we had a safer alternative? Yes, it would. And it turns out we do. So I'd like to introduce you to validating admission policies. Policies, not webhooks. So these were first introduced into Kubernetes in version 1.26 as an alpha. They went to beta in 1.28 and then became generally available and on by default in version 1.30. So if you're running an up-to-date version of Kubernetes, you can use these today, yesterday. They've been around for a little while now. What these are a declarative, in-process alternative to validating admission webhooks. And by that I mean declarative in that we define them as Kubernetes resources within our clusters. So there is a CRD that you create and define your logic. In process means that it runs within the API server itself. So you're not relying on deploying your own pods or external services. The API server handles all of this for you. So as long as the API server is running, your admission policies will work, which is not the case with webhooks. They use this thing called Common Expression Language, or CEL, which is what I'm going to be referring to as in this talk, and I'll come on to it shortly in more detail. And this is a policy language that allows you to write expressions for your policies to match against things. They consist of two main custom resources that you would use. There's a validating admission policy, which describes the actual logic of the policy itself. And then you've got a validating admission policy binding, which links that policy that you've created to the resources that you want to apply it to. So you need both of these for it to do anything, but it means that a single policy can have multiple bindings, and we'll come on to this very shortly. So before we get into that, I want to briefly go over what CEL is, because while it is now becoming more popular and including a lot more things, not everybody has come across it yet. It is an expression language. It's a very basic-ish programming language, let's say. And it's got a very similar syntax to a lot of C-based languages. So if you've done programming in any of the popular languages, you're probably quite familiar with the syntax. So here we've got like self.min_replicas is less than or equal to self.replicas, and self.replicas is less than or equal to self.max_replicas. So that means that if our min is 1 and our max is 5, as long as replicas is within those two numbers, we're all good. That's what it's going to match on. CEL is designed to be run as an embedded language within other tooling, like within other applications, which makes it really good for this use case. And it's also going to focus on what I like to call one-liners. It's not to create like 100-line applications. It's really just simple expressions, and it gets very complicated very quickly if you are trying to do a lot. It does have a few small built-in functions, so it has things like split, has things like that. We'll see these a bit later on. But it also has the ability to have custom functions as well that you can define for your CEL implementation in your application. So Kubernetes does come with a few custom libraries. You can see these on the documentation. I'm not going to cover them in this talk. But there is a few like Kubernetes-specific ones that you can make use of. You may have already come across CEL in other cloud-native tools. So Caverno, for example, uses it for some of its expressions. Tecton Triggers uses it to define some trigger filtering and expressions and stuff. And one of the things that I really like about it is it has this concept of a cost per operation, which actually can be calculated ahead of time before it even runs anything, which means that the API server, when running these CEL expressions, knows whether it's going to affect the performance of your system or not. So it can prevent like lockups and infinite loops and things like that because it has this concept of a cost. There's a few references to more resources down on the left if you are interested and want to learn more. Right, let's crack on. So an example. In my example, I'm going to use one of the ones that I mentioned earlier about blocking the use of the latest tag. So we want to make sure that our developers are only ever using tagged versions of images. We never want them to use latest because, vulnerabilities can creep in that way. We want to avoid that as much as possible. We want to use V1s and all that kind of stuff. So here we've got a validating admission policy. This is the first of our resources. First, we need to give it a name. This is what we're going to reference in our binding later on. In this example, it is prevent latest image tag. I'm very imaginative with my names. Next, we've got a failure policy. There are two options you can have here. There is fail and ignore. Generally, you're only ever going to want this as fail, which is the default. Ignore is like if you want to then disable the policy temporarily, for example, where you're trying to debug what's going on or whatever. Excuse me. And then we've got some match constraints. So this is what the policy will actually apply against. In this example, we're using some resource rules that are going to say anything within the apps API group and is a resource of deployments, daemon sets, or stateful sets, if you can read that with the way that the screen is. Whenever the API call is a creation or an update, so a kubectl apply, a kubectl patch, whatever, against one of these resources, this policy will then apply. If it's not one of those, this policy gets ignored and is not relevant. We've then got a message. If we don't include, this is a human readable message, this will get shown to the user when they do a kubectl apply or whatever that fails the policy. This is optional, but I highly recommend that you put this, because if you don't put this, the error that the user gets is the CEL expression, and it's not very human friendly, and it's just a big mess. And then we've got the actual expression. So this is what we're going to use to actually do our logic. Now, one thing that always catches me out, even though I've been doing this for a while now, is the expression is actually to match against what is allowed, not what you are trying to block. I always get it the wrong way around. So the expression has to match if it's a valid, allowed policy, not if it's the thing you're trying to block. So even though I've called this prevent latest image tag, what we're actually saying, what the policy actually is does not have image tag. You know what I mean? So let's have a look at what this is. So we've got this special property first called object. This is provided by the Kubernetes implementation of CEL. An object here is will refer to whatever the resource is that we're applying the API against. So in our example, it's a deployment, a daemon set, or a stateful set, depending on what the API call the user made is. Now, one thing to keep in mind here is the spec of all of these, the deployments, daemon sets, and stateful sets, is pretty similar for the most part. Like they have a spec.template.spec.containers, and that's what we're going to work on. If these had very different schemas, this won't necessarily work because you won't be able to then easily write your CEL expression that will match against both of them. You'll then want to have multiple policies. So in this example, we are doing spec.template.spec.containers, and then .all is one of these built-in functions that I mentioned earlier. So this then allows us to run an expression against all items within an array. So the containers property in the spec is an array of container objects, and then for each of the container objects, oh, I've gone too far. For each of the container objects, we're going to make sure that container.image, and again another function, ends with, it's kind of a bit cut off there, but latest, and it doesn't, and that it does contain a colon. So what we're doing here is checking against whether the tag in the image is latest, or whether it's not provided at all, which then implicitly infers to latest. And because we also then want to check on init containers, which are not a required field on the spec, we then have to use this has function, which checks first if init containers is defined on our spec, and then if it does, we run the same logic against the init containers as well. So if it's an optional field, make sure you have that guardrail in, otherwise your CEL expression can fail for it not existing. Cool. So now we've wrote our policy, we've got to have our policy bindings. Without the binding, it does nothing. So again, I gave it a name. I matched the same thing. And then in my spec, I just need to reference the name of the actual policy that I defined earlier. Prevent latest image tag. And then we've got validation actions. Note here that this is an array of actions. The valid actions you can have here are deny, warn, or audit. The only reason this is an array is it's possible to supply both warn and audit at the same time. Supplying deny implicitly implies audit anyway. Deny is generally what you'll want here, but you may want to go for warn initially as you're transitioning to using the policy to see what the effect's going to be when you turn it on. Like if you put a policy in with warn and you get hundreds of things that are then going to get blocked, you may need to go and have a word with your app teams before you turn this on. And then match resources, this is where we will define what this binding will be applied against. So we can limit our policy against a specific namespace, for example. So in this, I only want to apply this policy against a namespace that has the label on it that is environment prod. So in this fictional cluster, we have namespaces for different environments. And in the prod environment is the only one that we really care about applying this policy. In the dev environments or whatever, they're fine to use lattice. We'll allow that for now. But prod, we want to make sure it's safe. And that's what this will then apply to. All others will get ignored. So here's an example. On the left, I've got a deployment trying to deploy Nginx. Right down at the bottom, you can see I'm trying to use the latest tag. And when I try and apply this, I get this very nice human-readable error message that tells me the latest tag is not allowed, and it has blocked me applying that. And that's it. That's nice and easy. That was all done within the API server. Nothing can break in terms of a pod going down that would then prevent that. So let's look at some more advanced features. So that was pretty easy so far. We all up to speed? There's more context variables we can use. So we saw the object property in our example, which references the resource that the API call is against. We've also got the old object and request properties that we can use. So if your API call is an update of some kind, so a patch, a delete, whatever, old object will also be applied, so you can do a comparison between the two. So you can prevent certain changes happening that you don't want to allow. And then we've also got this request object. So this gives you more information about who and what is making the API call. So in this example I've got here, in my cluster, I trust the kubelet. And I want the kubelet to do whatever it wants. I trust it. So I've got an expression here that checks whether request.userinfo.groups contains system nodes. And this is what the kubelet gets in a standard setup. If that is true, do what it wants. Kubelet, I trust the kubelet. Next, we've got parameters. So as I said originally, we have two main CRDs, the policy and the binding. But it's also possible to use additional custom resources to define parameters. So if you want to create a policy that can be dynamically used in different ways, maybe in different namespaces, you can do that with parameters. So in this example, I'm defining here on the right in my policy a param kind, and I'm saying it's this rules.example API version, and the kind is replica limit. So this is a CRD that I've just made up. And the validation here is my object.spec.replica, so let's say this is a deployment, has to be less than or equal to my params.max replicas. So I am enforcing a minimum number of replicas that my deployments have to have. I've then got my policy binding, and as I said at the beginning, we can have multiple policy bindings per policy. So in this example, my policy binding is giving a reference to a parameter using this param_ref called my parameters in the default namespace, which you can see here on the right. And this just has max replicas.3. So when this policy binding is applied, params.max replicas would be 3. In a different namespace, for example, in my production namespace, I may want the minimum number of replicas to be 10. So I could have another params.yaml, another binding, using the same policy and have a different minimum that it then matches against. Now, I've also got variables, which are not to be confused with parameters. Variables are basically reusable CEL expressions that can help simplify your validation expressions. As I said at the beginning, CEL is really aimed at one-liners. Once it gets long, it gets confusing. But you may want to reuse bits of CEL a few times in your expression, perhaps. You can do that with variables. So a variable, you give it a name and you give it an expression. One thing to be aware of, the name has to be a CEL valid name, not a Kubernetes valid name, which means you can't have hyphens in the name, but you can have camel case. Catches me out every time. So in this example, I am defining a variable called team label. And team label is an expression that will check for the team key in object.spec.metadata.labels. And here we're using a ternary operator. to check whether it exists first. And if it does, we'll grab the value of the team label. And if it doesn't exist, we're going to default to no team. And we can then use that in our validation to say, if variables.teamLabel, which equates to that, is equal to releng, that's when our policy will then apply against it. If it's a different team, doesn't apply. And then we can have like multiple of these however we need. You've also got audit annotations. So I mentioned earlier that one of the things you can have is to have it go into your audit. Here you can add basically extra metadata that shows up in your audit log when one of these fails. So you've got this audit annotation, and you give it a key and a value expression. So the key is just a name of whatever you want it to be, and then your value expression, again, is a CEL expression that you can use, and that will then get applied into your audit event as an annotation. So here we've got, you see it actually gets prepended with the policy name, and then / the annotation, the key name that you gave it here, and it gives it the value of whatever that equates to. So in this example, deployment.spectral set to 128, which we don't want in this case. You can, again, multiple of those. Finally, message expressions. So we saw earlier, and I was pretty adamant that you should be using messages for your validation so that the people facing your error messages knows why it's gone wrong. Alternatively to message, you can use message expression, which allows you to then use a CEL expression within that value to allow you to have more dynamic error messages shown back to the user. This is very useful if you're using parameters, for example, because it allows you to say, for example, object.spec.replicas must be no greater than whatever the value of params.maxReplicas is. So in our example earlier, that would be 3. In our hypothetical example, it could be 10, whatever. And that then at least gives your users the actionable information as to what they can fix to not get the error. Cool. How are we doing? So that's validation covered. What about mutating? So we've got mutating webhooks are a big thing. We saw that fixes the log4j thing. Well, let me introduce you to KEP 3962, mutating emission policies. Fortunately, it's not merged in yet. It was aiming to go into Kubernetes a few versions ago, but there's been complications that have prevented it from getting in. It's still, at the moment, currently targeting 132 for alpha. Let's see whether that actually happens or not. I'm hoping, but there's been some issues because CEL's not really designed for this kind of thing. But it follows the idea at the moment is it follows the same idea as validating emission policies. Introduces 2 new resources, a mutating emission policy and a binding. And at least last I checked, supports 2 patch strategies, so apply configuration and JSON patch. Phase 1 of the planned release of this will only support adding and updating of values using this mutation. You will not be able to unset values in your resource. You can't remove a value that's applied. That may come in a later phase, but CEL doesn't have any capability of doing that in the language. And again, it's not yet finalized or available for testing unless you want to build from the branch that they're currently building this on. Let's have a look at a very quick example. It's very similar to what we've already seen. So again, we've got our match constraints. In this example, we're matching against the creation of new pods. And then we're going to define a mutation rather than a validation that we had earlier. The patch type is, as I said, one of these 2. It's either apply configuration or JSON patch. Now, when we get to our mutation, this is where things go a little bit different. We've got this concept of a named type. So object here is a type. And in here, we've got, in here, this is actually going to be pod, because that's what we're referring against. And we're going to say that we're going to apply on spec containers, object.spec.containers, item. And for all of the environment variables, we're actually going to inject a new environment variable. So this example here, we want to automatically inject a HTTP proxy environment variable into all pods within our cluster because we're using a lockdown cluster or whatever that we don't want to have direct access to the internet, but we don't want to have all our app teams manually add this environment variable. Let's do it automatically on creation. And this will then inject that environment variable into every single container that gets created in every single pod. And again, we've then got a binding that actually makes it do something. There's no validation actions because it's not a validation, it's a mutation. And we've got no resource takes. We want it to apply to everything within our cluster. Cool, so what is beyond that? Now, what's coming next is more hypothetical and my wish list for what's coming in the future. But what I would like to see is generative policy. So this is the ability to create new resources based on API actions. So for example, being able to create maybe a config map based on a certain CRD being created or something like that. The ability to do resource lookups for existing resources within your cluster. This is not currently possible with CEL, mainly because of the cost implication of doing another API call within the API server. You can end up with like a locking mechanism. A deadlock. Policy exceptions is not a thing yet. So there's no way for a particular application to have an exception to a particular policy for whatever reason, which is quite a common use case for a lot of the webhooks. And then more abstraction. So I know Kubernetes are already working on implementing this, but I imagine more and more tooling, as this becomes more implemented, will also build on top of the validating emission policies rather than webhooks because they're safer in terms of what impact they have on the cluster. So in summary, it's time to start replacing those risky webhooks with in-process policies, if possible. Validating emission policies are available to use now, so I highly recommend you try them out. Keep an eye on that KEP that I mentioned about mutating admission policies. Again, I'm hoping 132. Let's see. I'm keeping an eye on it. And then hopefully in the future we'll have like more abstractions, more generative, more fancy stuff. Thank you very much. If you have any feedback, please let me know. The link for these slides are there. And I believe I've got time for questions.
Yes, of course. Thank you, Marcus.
Cool. Thank you very much.
Any questions?
I can't see a thing. So.
Hello, how you doing, Marcus? Thank you very much for that session. Just a couple of questions I was jotting down as I went through. And full disclosure, I designed and worked on Gatekeeper, if you've ever used that. So, so a lot of that informed some of this work. Great. So does that mean I'm going to get hit?
we use Kubernetes. I'll just preface it.
No, that's okay. We love Kubernetes too. We work with them closely. So, you know, rising tide lifts all ships. A couple of things on the parameters. Can you have? I noticed you had just a string. Can you have arrays and lists and other types? Let's say instead of latest you wanted 1.32, 1.31, 1.30. Can you pass an array in for max replicas, or is it just one value?
I'd have to look it up.
Okay, that's okay.
I don't know off the top of my head.
No, that's okay. And this isn't a quiz because I don't know either. Because I think, you know, what I usually see is with, you know, latest, you'd actually have a fixed number of labels that you're okay with, or shars or something like that. I'll take a look at that too. The other thing is on the match conditions. I noticed you had workload APIs, deployment stateful sets. Now, if you're applying a policy at that level, should you not apply it at pods as well? Because if a user goes to create pods, like, what's your best practices there?
Good question. So that's going back to
one of the very early slides.
For example, so in this example, I'm applying it to deployment statement sets and stateful sets. The reason my example has this is because they all have spec.template.spec.containers, whereas pods...
It's nested, only has spec.
Exactly, so
spec
that won't
containers.
work.
Won't work, yeah.
Pods, I'd have to have another policy.
So what do you typically do at that level? Do you block pod creation apart from controllers? Because you know how you were granting, you know, the workload APIs. I've always wondered, how do you grant them, like the kubelet example you had, dedicated access to create these things, but not the person using kube control? Because presumably you have that system locked down.
So generally, try and avoid applying things to the kube system namespace, for example. That's, you know, have RBAC and stuff apply security around that, and then let your actual users use everything else. So you can have that as kind of a special exception case. But this is where I'd like to see policy exceptions coming in the future to be able to do exactly what you're saying. So you could say, yes, this very trusted controller has to have these permissions. I want to also apply a policy exception that would allow that. I think that's going to come in the future, but we're not there yet. I think Gatekeeper's got exceptions, right? Yes, yeah. No, yeah, I think it's going to come At the moment, you've just kind of got to work around it a little bit, yeah. Thank you very much. Good, good. Do you want to get set up?
I could just start setting up.
One more question.